Philo of Byzantium was the very first person to make a device that measures temperature, and it looked a little bit like this. Obviously, this isn't the same one that Philo made 2,200 years ago, but it works in the exact same way. When it's surrounded by something that's warm or hot, the air inside expands, pushing the liquid in the bottle down and up through the straw. And the exact opposite happens when it's surrounded by something that's cold. But strictly speaking, this isn't a thermometer. It might act like a thermometer, with a liquid going up and down the straw depending on whether it's warm or cold. But because it doesn't have a scale, or a meter, it's not a thermometer, it's instead a thermoscope. And it's because of that it doesn't have a scale that it's kind of useless to us. But nowadays, we can use a much more compact and practical digital thermometer. And it says right now in this room it's 14.1 degrees Celsius. So it's fairly cold. But what is the coldest thing in the universe? First, we have to define temperature and distinguish between cold things and hot things. And what we can say that the temperature for any system, like a banana, a collection of molecules and atoms, is just the sum of the kinetic and potential energies that make up the system itself. Meaning that hot things are just highly energetic molecules that may be moving and vibrating around in a fixed position. And cold things are just molecules that aren't that energetic. From this, it's obvious that the coldest object in the universe must just be an array of zero energy molecules. And that's it, problem solved. Kind of. Because they're molecules, there's by definition some intermolecular forces keeping the particles together. And that causes the particles to move ever so slightly. And it's because of this slight movement that the internal kinetic energy slightly increases, meaning it's not quite absolute zero. It's not quite the lowest temperature it can be. But we can kind of get rid of that issue by just looking at one individual particle. We can't get the lowest temperature, absolute zero, by looking at a bunch of particles, but if we just look at one, we might be able to get there. Going back to our previous statement, this one particle must have zero internal kinetic energy. And it can only really do that if its position is fixed and there's no change in momentum. There's no change in position, there's no endeavour for it to move. And if we could find a particle that did that and had those properties, then it would be the coldest atom. It would be the coldest object in the universe. We can say that the temperature of this one atom is going to be roughly negative 273.15 degrees Celsius, or negative 459.67 degrees Fahrenheit, or, which is much easier to say, 0 Kelvin. And that is absolute zero. That is the temperature of absolute zero. And it is incredibly, incredibly cold. However, because we're talking about one individual particle, there are some strange quantum effects taking place. More namely, the Heisenberg Uncertainty Principle. And this one principle, in a way, kind of acts as a backbone for which the rest of quantum mechanics is built upon. And so we definitely cannot just ignore it. And the equation itself that Heisenberg derived was this: that the change in position multiplied by the change in momentum must be greater than or equal to h over 4 pi, with h being Planck's constant. The principle, in short, states that the more precisely you define a quantum particle's position, the less you define the quantum particle's momentum. Meaning you can never truly understand its position, nor its momentum exactly. Now, if we had a particle and we perfectly defined its position by the Heisenberg inequality, we've perfectly undefined its momentum. And you can say that there's some quantum haziness about its momentum itself that will tend to fluctuate randomly backwards and forwards. And it's that quantum haziness, that random sparseness of momentum, that causes its internal kinetic energy to slightly increase from absolute zero. Meaning that the lowest temperature you will ever get, and is possible in the entire universe, is slightly above, but never, absolute zero. In fact, just 3 months ago, on the 30th of August 2021, a group of physicists set out to get the lowest temperature ever to be recorded. And they got 38 trillionths of a Celsius above absolute zero. There's no definite definition for the highest temperature, but there's definitely a limit for the lowest temperature, that being absolute zero, which is technically not even possible to get to. You can see my cat over there in the corner. Ready! I'll get you in a minute. I need to finish off edit this video quickly, okay? Can you see that? Birdie, wait 1 minute, okay? I'll link the video down in the description of exactly how the team managed to get the lowest temperature, and he's gone. And anyway, I'll see you all in the next one.